Hi, and welcome to week 4 of the TheMathsTutor.ie 30-week countdown for Leaving Cert Ordinary Level Maths. So just a reminder that the full countdown is available on the TheMathsTutor.ie website, and that's for all the full members, and it has all 30 weeks of the countdown. Also on the website, there's going to be lots of videos to give you a help with all the Leaving Cert Ordinary Level Maths, but there's 2 videos that I've picked out for everyone for this lesson, and the first one is on interpreting graphs. So this is going to help you with interpreting graphs, because this week we're going to be looking at quadratic functions and graphing. And the second video that we've picked out there is on plotting quadratic functions. So this is going to help to draw your quadratics and show you how they can be drawn. So this week we're looking at quadratic functions, and we're going to be looking at interpreting functions. So just to remind you of what a quadratic looks like in its written form. So how will I know that I'm dealing with a quadratic? So when I'm dealing with a quadratic, we normally have a letter to be squared, and then we'll have plus or minus the same letter, and then we're going to have plus or minus a constant. And the constant may not be there. So a constant, remember, has no letter attached to it, so it's just a number. The constant may not be there, so I can treat the constant as 0. The same letter may not be there. There might be no of them, but something that we would often see is something like x squared minus 4x plus 6, or something like this. So that's an example of a quadratic where we have the letter being squared, the same letter, and then a number. Just watch the order as well. So sometimes the letter to be squared could be at the end. So once I see the highest power of my letter is square, that tells me that I'm dealing with quadratics. So today, as we said, we're going to be looking at quadratic functions. So we're going to be looking at graphs of these quadratics. So just a quick reminder of what the general shape of quadratic graphs are. There's 2 different general shapes that we need to be aware of. One is when we have an x squared graph, and one is when we have a minus x squared graph. So when we have an x squared graph, we describe this as being a positive quadratic, and a positive quadratic is always going to be what we call U-shaped. So when we plot our points and join them, we're going to get a U-shaped graph like this. And if we have a minus x squared graph, we're going to get a negative quadratic. And a negative quadratic is always n-shaped, so it's going to be like this. And we remember this because negative starts with the letter n, and this is an n-shaped graph. So that's a kind of a clue. When I look at my quadratic and I look at to see, do I have an x squared graph or do I have a minus x squared graph, it's going to give me a clue of what should it look like when I find my points and I plot them. It doesn't have to be just x squared or minus x squared. It could be 4x squared or minus 12x squared. So there could be a number in front of the x squared as well. But what we're looking at is what is the sign of that coefficient. So what sign is in front of the x squared? And that's going to decide what shape we end up with. So we're going to look at a couple of questions from the papers on our quadratic functions and interpreting these functions. So the first one that we're going to start with is 2020 paper 1 question 5. And we're just going to start looking from part B here. So part A was just about solving a quadratic, which was done in week 3 of the exam countdown. So here we're going to look at plotting. So part B, part 1 says complete the table below to show the value of the function f of x is equal to minus x squared minus x plus 6 for each of the given values of x. So we want to get a table of values, and they're not really giving us any space to do the working. So that's telling me that I'm going to be doing this on my calculator. I also see here that we have this minus x squared term. So when I have a minus x squared, because in part 2 it's going to ask me to graph it, I'm expecting an n-shaped curve. So I'm going to be getting a negative quadratic, so an n shape. I need to work out what these points are going to be though. So I'm going to use my calculator to do that and save me having to do all the working out each of the points individually. So just to show you how we do that on our calculator, is we go into table mode. So this is the newest version of the Casio. We press this setup button here, and the third one here, number 3, is going to be the table. So we can either move across with the arrows, or we can press number 3 and it's going to bring me to this function. So what I'm going to do is I'm going to type in my quadratic. So my quadratic was minus x squared minus x plus 6. So to type that in, I'm going to press the minus button here first to put in a minus, and then I want to put in an x. Now, it doesn't matter what my quadratic looks like. So we'll see a quadratic that has t's in it. You might see ones that have y's in them, but my calculator, I'm always going to just put them in as x because it says f of x. So to put in an x, I see over this close bracket here, there's an x written in red writing, and to use the red writing, I need to use the alpha button. So I press the alpha button and then the close bracket, and it gives me my x. So I've started my function, so minus x, but this was minus x squared. So when I press this button here, I get my minus x squared. So that's my quadratic started. The rest of it then was minus x. So we put in the alpha x again, and then it was plus 6. And I press equals to say that's the function that I want to work out the points for. So we press equals. The new version of the calculator then says, do you want to put in another function? So g of x. I don't for this one, so I'm just going to skip over that by pressing equals. And then it asks me where I want to start. So we just have a quick look. Where did the table start? The table started at -4 and the table finished at 2. So they're going to be my start and end. So I want to start at -4 and I press equals to tell the calculator that. And I'm going to end at 2 and I tell the calculator that. And then the last thing that I have to tell the calculator is what steps I'm going up in. So this is the difference between my x values. So my x values on my table went -4, -3, -2, -1, 0, 1, 2. So they're getting bigger by 1 each time. So my step is 1 and I press equals. And here I get a table. This part here is all my x values. So -4, -3, -2, -1. They're the x values. And what the calculator has worked out are the y values for me. So we see -6, 0, 4, 6, 6, 4, and 0. So we're going to go and write those into our table for our answers. So for -4, we had -6. For -3, we had 0. For 2, we had -2, we had 4. So that's great. So that is the value that was on the table. So I know that this is going to be right. -1 was 6. 0 was 6. 1 was 4. And 2 was 0. So I've worked out each of these functions. So that's what this f of x here is telling me, that this is a function of x, and I'm going to be getting an answer. So we'd often call them the y values or the f of x values. When I'm graphing it, I'll always be calling those y's. Sometimes we call them the outputs or the range. So that's our first part. We've got our table of values. And once we have our table of values, the second part of this question has this word hence. So when we see this word hence, we know that we have to use the answer that we've just got. So it asks us to draw the graph of f in the domain -4 less than or equal to x less than or equal to 2, where x is an element of or on the diagram below. So x is an element of or is just telling me it's a real number. So that's going to be a smooth curve. I'm going to have all my numbers. From -4 to 2 tells me they're the x values that I want to use. So the domain, these are the x values, and they're the numbers that we're going to put into our function. So we saw the calculator took those numbers because that was what was up here on the graph from -4 to 2. So we're going to take each of these x values and corresponding y values and draw a point. So the first one said when we had x was -4, our y value was -6. So that would be the point -4 -6. So to draw that, we would just get our graph and we would go across to -4 and down to -6 and draw our dot. The second one was -3 and 0. So -3 and 0 is going to be on the x-axis. So I'll draw my dot here. The next one is -2 and 4. So I go across to -2 and up to 4, and I draw my dot. The next one is -1. So I'm coming across to -1 and up to 6. The next one is 0, 6. So I don't go across, I just go straight up to 6. 1, 4, and the last one is 2, 0, 0. So I can already see that these look like that N-shaped graph. Now, it's not very smooth drawing it on this here, but what you would do is draw a smooth curve joining those points. So we don't use a ruler or anything like that, and it should be going through the points. Now mine is very messy there, so that's the idea, but you can see over here that I have the answer copied over, and this is what a lovely smooth curve here would look like. So when we plot those points, we're going to plot the points and draw a smooth curve. So don't try and join them with a ruler. We're going to have a nice smooth curve joining each point to the next, and there's our general N shape. So the general N shape is important to keep in mind in case I did any sort of mixing up an X and a Y, and instead of plotting the point 2, 0, I might have plotted the point 0, 2, and suddenly I'd be bringing this down and then back up and going, that doesn't look right. It's not a smooth curve. So I would just go back and check my point again. So that's how I find my points on my calculator and how I plot my points and draw my curve. The next part of this question then asks me something a little bit different. So this time it says, on the same diagram as the function f, draw the graph of the function g of x, which is equal to f of x minus 2 in the domain of minus 2 is less than or equal to x, less than or equal to 4, where x is a real number, and label the graphs of f of x and g of x clearly. So now it's asking me to draw another function. All it's telling me this time is that g of x is equal to f of x minus 2. Now I have from minus 2 to 4, so I've got a different domain this time. So it's not the same one. The first one was from minus 4 to 2. Now we're looking from minus 2 to 4. So we've got different points here. There's a couple of things that we need to be aware of when we're doing a graph. So we have a couple of things that we can do that's going to move our graph around. So the first thing is, if I take a graph of a function, so f of x, and I add a constant to it. So outside the bracket, I'm going to add a constant. That's going to shift the whole graph up. So I might get a question that says, okay, draw another graph g of x, and we just use g of x because it's the next letter. F of x, we often use f because it's like, oh, there's a function of f. Now we've used the letter f, I'm just going to pick the next letter of the alphabet. So the same way that we'll often say, something I don't know is x, the next thing I don't know, I'm going to call it y. So this is just draw a g of x. So this one might say f of x and add 2 to it, or f of x and add 4 to it. And what this does is that if I'm adding a number outside the bracket, it's going to shift the graph up. If I subtract a number outside the bracket, it's going to shift the graph down. By that many boxes. So that's the first sort of a change that we can have. And that's when we put this constant outside the bracket, and that's going to move it up and down on the y-axis. This one, though, is inside a bracket. So when I look at this one here, we see that we have f of x minus 2. So this time the minus 2 is inside the bracket. So it's a slightly different change. So if I have f of x plus a inside a bracket, or f of x minus a inside a bracket, this time we're going to be moving the graph left and right. So we're going to shift the graph. And if it's a positive a, we actually shift the graph to the left. And if it's a negative a, we're going to shift the graph to the right. So this question says g of x is equal to f of x minus 2. So I can see that that's this last example here. So I'm going to be moving my graph 2 units to the right. Okay, so g of x is equal to f of x minus 2 tells me to move the graph 2 places to the right. Okay, So we have to label our graphs f of x and g of x carefully. So this is a very messy looking f of x here. So I'm just going to rub out the actual messy lines, but we would label that that was f of x. We're now going to move all of our points 2 places to the right. So that's what this told us to do. So we'll just pick a different color and we're going to move them all 2 places to the right. So this one down here is going to move 2 places to the right and ends up here. This one here, which was minus 3, 0, is going to move 2 places to the right and it ends up here at minus 1, 0. I'm going to do the exact same thing. So I just move them over by 2 places each and draw my new dot. Now you don't have to draw the lines that I'm drawing in green here. All you have to draw are the new points like this. And when we would join those up, we'd see that we'd get a new quadratic. So we're going to get another N-shaped curve, but the whole curve is going to have moved over by 2 spaces. And I'm just going to label that that one is g of x. So again, it's a little bit hard to draw them on this screen here. So we've taken a picture of the answer, and this is what our answer looks like. Here's our original f of x graph. So a lovely smooth curve. Sorry, that's the wrong pen color. So our f of x curve, we plotted in blue points and we would join them up. And we can see that the whole curve has moved over by 2 on our g of x, and we would mark that. So that's what that question was asking us to do, was asking us to move the graph. If it had been outside the bracket, then we'd be moving the graph up or down. So we might have seen f of x plus 2 like this. And that would tell me move each of my points up by 2. So I would just take each point and move it up by 2 and the whole graph would move up. So that's something that doesn't come up that often, but we do need to be aware of it when we spot it, when it's translating or transforming one of our graphs. And that's our 4 different ways that we can do it. So we can add a number outside the bracket, subtract a number outside the bracket, or add or subtract a number inside the bracket. Okay, so that's our first quadratic graph. The second quadratic function that we're coming across here looks a little bit different. So this is a question 7 from paper 1, so 2019 paper 1 question 7. And this time, instead of just a straightforward find the points and plot the graph, this time it's going to be from your section B, so there's going to be a little bit more of a story to it. So this says a camogie goalkeeper on a level pitch hit a ball straight up into the air. The path that the ball traveled can be modeled by this function. So f of t is equal to minus 4t squared plus 16t plus 1, where t is an element of r. And it says where t is the time in seconds from when the ball is hit, and f of t was the height of the ball in meters above the pitch. The ball landed on the ground without being hit again. So there's a couple of things that look a little bit different here. So this time I see that we have f of t rather than f of x. So that just tells me that my letter is a t squared and a t and then a constant. But I'm going to treat it exactly the same way that I did my f of x a minute ago. It does tell me that f of t is the height of the ball. So the function is going to be giving me how high does the ball go as my variable t time changes here. Okay, so the first part of this question is saying at what height was the ball when it was hit by the goalkeeper. So if I get a question like this, this is asking me at the beginning. So what height is the ball at the beginning? So remember that this function here, f of t is equal to minus 4t squared plus 16t plus 1. This is telling me what height it is at any particular time t. So at the beginning, t is equal to 0. So all we're going to do is we're going to sub in 0 everywhere we have a t. So I can say f of 0 is equal to minus 4 times 0 squared plus 16 times 0 plus 1. And when we put that into our calculator, that gives us an answer of 1. And my units here, it says f of t was the height in meters, so 1 meter. The second part of this question then says, complete the table below to show the height of the ball at various intervals during the first 4 seconds of its flight. Now they've given us space to work them out this time, but we're still going to do it on our calculator. What's a little bit different here is that my function is given in terms of t, but I'm still going to put it into my calculator as x's. And this time I see the gap is different. So the gap this time goes 0, 0.5, 1, 1.52. So I can see that it's actually increasing by 0.5 each time. So that means that when it asks me about the step, I'm going to be saying 0.5 rather than saying 1. So we're just going to switch over to the calculator again, and we're going to clear that one. Okay, and I'm still in function mode. So just to remind you that I press menu and table 3, and I'm in function mode, and I'm going to type this in. So -4. I don't have an x because this is f of x. I don't have a t, excuse me, on the calculator. This is f of x. So I'm just going to go alpha x instead of t squared plus 16x instead of t plus 1. And I put that into my calculator. I don't have a g of x going in at the same time. This time I'm starting at 0 and I'm finishing at 4. So the end is going to be 4, but the steps were 0.5. So instead of having one gap between them, we actually end up having gaps of 0.5. So 0, my y value is 1. When x is 0.5, my y value is 8, and so on. And I'm going to take all those values from my calculator and put them into my table. When I'm finished with this mode on my calculator, I press menu again, and I come back to number 1, which is just my normal calculator, how I can use it. So we're going to transfer those figures into our table. So the time when the time was 0, the height was 1 meter. When the time was 0.5 seconds, the height was 8 meters. When the time was 1 second, it was 13 meters. 1.5 seconds was 16 meters. 2 seconds was 17 meters. 2.5 was 16. And again, that's a lovely little check just to know we're on the right track. 3 seconds was 13 meters. 3.5 seconds was 8. 4 was 1. So they're my points that we're going to have to get the height of the ball at these different intervals during the first 4 seconds of its flight. And then it's going to ask me to draw the graph to show the height of the ball when it was in the air. So one thing we didn't point out was we had a -4t squared. So again, we're having this negative coefficient here in front of our squared part. So that means I'm expecting an n-shaped graph for this quadratic as well. So when I come down and plot my points, at 0 seconds we had a height of 1. At 0.5 seconds, so halfway between the 0 and the 1 on the x-axis, we're going to have a height of 8 meters. At 1 second, we're going to have a height of 13 meters, excuse me. At 1.5, it's going to be a height of 16. At 2, it's going to be a height of 16. 17. At 2.5, it's going to be a height of 16. At 3, it's a height of 13. At 3.5, it's a height of 8. And at 4, it's a height of 1. So we would again join those as a nice smooth curve, and we would get our n-shaped graph. So I can see that they're going to make an n-shaped graph. The next part, part C, is going to ask me to use that graph. So we're going to have our answer here again. This is what our smooth graph would look like when we plot it and join them all together. The red lines are going to be the answer for the next 2 parts of this question. So the next 2 parts of this question say use your graph to estimate, and you have to show you're working on the graph. So there has to be workings on this graph to be able to say this is where my answer is coming from and this is the answer that I got. So the first thing that it asks me is the length of time the ball was in the air from the time it was hit until it landed on the ground. Now, our last point was this point here where we had 4 seconds and a height of 1 meter. So what we would have to do is extend that further. So you can see that this line has been extended to the end of the curve, and we need to mark that that's what we're interested in. So this little red dot here, that's my workings. That's showing that I'm saying the ball is going to hit the ground here, and we're going to estimate what that time is. So looking at this, they're estimating 4.1 seconds. So the length of time the ball was in the air from the time it was hit until it landed on the ground is 4.1 seconds. And to get my full marks, I'm making sure that I show that on the graph. The second thing that they're asking me to do on the graph is find the length of time the ball was 10 meters or more above the ground. So we're going to go back up to our graph, and we're going to draw a line across at 10 meters. So we just take out your ruler and we would draw a straight line across at 10 meters. And I'm interested in how long is it above 10 meters. So this is above 10 meters in all of this section up here. So all of this section here, it's above 10 meters until it comes back down to this blue line. So I'm saying, well, when did it reach this 10 meters? So I would take out my ruler and join down to the x-axis and read off when did it reach 10 meters. So from this, the estimate is 0.6 seconds. And then I would say, well, where did it come back under 10 meters? So again, I would take out my ruler and join down until I reach the x-axis, and we're estimating 3.4 seconds here. So above 10 meters or 10 meters or more, from 0.6 seconds to 3.4 seconds. And my workings are on the graph. And all we would do then is do that subtraction and find that it was 2.8 seconds above the ground, 10 meters or more above the ground. And there's a little bit of leeway there. So if you get a slightly different answer because you're reading from your graph, you will get your full marks. The last question that we're going to look at today then, this is where we're going to be looking at solving a quadratic and picking out which graph goes with that quadratic. So in week 3, we looked at solving quadratic equations, and we said we could use the minus b formula, or we could factorize by inspection or by using the guide number. And once we find those factors, we can take each of those factors and solve to find the roots. So when I'm factorizing, I split up the first term, which was an x squared, to put an x into each of my brackets. And I look at the last term, which was a 6. So my factors are 6 times 1 or 3 times 2. And I want the factors that subtract, because there's a minus here, to give me the coefficient of this middle term. So I'm going to take the 3 and the 2. So we put a 3 in one bracket and a 2 in the other. And I want to get a minus x. So it's minus 3 and plus 2. So if we did a quick check on that, the first term by the first term would give me x squared. The first term by the last term would give me a plus 2x. The last piece of the first bracket by the first piece of the second would give me a minus 3x, and the minus 3 by the plus 2, excuse me, would give me a minus 6. And when we tidy that up, we'd get x squared minus x minus 6 equals 0. So I know that they're the correct factors. But we've been asked to solve. So remember, when we see this solve, I know that I want to get x equals. So we take each of our brackets and we put them equal to 0 and solve for x. So the first one, I'm going to solve by adding 3 to both sides. So I get x is equal to 3. And the second one, I'm going to solve by subtracting 2 from both sides, and I get x is equal to minus 2. And that's the answer for solving this equation. So I'm going to get the answers of x equals 3 and x equals minus 2. They're called the roots of the equation. So we came across that in week 3, that they're the roots of the equation, and the roots of the equation are where it crosses the x-axis. So part B of this question says the graphs of 4 quadratic functions are shown below. Which of the graphs above is that of the function f of x goes to x squared minus x minus 6, where x is an element of R? So this function that they're asking me about here is the function that we were looking at, or the quadratic that we were looking at in the first part, x squared minus x minus 6. So there's 2 things I'm going to use to work out which graph is this function. The first is the fact that the coefficient of this x squared term is positive. So when it's positive, I'm expecting a U-shaped graph. So when I look at my graphs A, B, C, and D, I can rule out graph B because it's N-shaped. I can rule out graph C because it's N-shaped. So now I'm saying it's either graph A or it's graph D because they're both U-shaped. The difference between these two graphs are where they cross the x-axis. So when I look at graph A, I see that the roots are -3 and 2. Up here, we can see that our roots were 3 and -2. So they're not going to be the roots that we wanted. Whereas when we look at graph D, my roots are -2 and 3, and they're the roots that we got from our part A of it. So our roots are -2 and 3, and it's an U-shaped graph, which means that we expect graph D to be the graph of the function. Okay. So hopefully that has been of some use to you with looking at quadratic functions. And don't forget, there's 2 videos there, one on interpreting graphs and one on plotting quadratic functions. And for those of you who are full members, the full countdown revision schedule is on TheMathsTutor.ie.